Hi, today we're going to talk about two-step mole problems. So I want to just go back to our mole town and just remind us of where everything is. So in the middle we have our moles, then we have mass, volume, and particles. Remember, particles can have molecules, atoms, compounds. Those are all possible units for particles. Possible units for mass is grams, and possible units for volume is liters. And the mole center is moles. So far we have learned how to go from outside in and inside out, right? Just one-step problems. Today we're going to do multi-step problems. And when we do multi-step problems, we have to make sure that we're only following the lines that are given. So if we had to go from mass to particle, we can't make our own line here, right? Remember, we call this mole town. We have to follow the roads that are there. We're not making any back roads. So what we're going to do is if we are going from particles to mass, we would have to pass through moles in order to get through to mass. So moles, it's called the center because it is going to be at the center of all of our conversions. So let's see how this works. All right, so number one says, how many grams of CO2 are there in 4.27 times 10 to the 24th molecules of CO2? So what we have to do first is figure out what we're being asked for and what we're being given. So it says, how many grams of CO2 are there in 4.27 times 10 to the 24th molecules of CO2? So we always start with the number that's given to us, and then we're getting to our new units. We're going from molecules to grams. So molecules is in particle part, and grams is in mass mole. So in order to get there, it's going to be one step to the center, and then a second step to grams. So I'm going to set up a conversion table, or our train tracks, for 2 steps, right? 2 steps means 2 vertical lines. I always put what I'm starting with in my top left. So that is the number, the unit, and the substance. Now, I'm trying to get out of molecules. So that goes on the diagonal because that is dividing. Now if I go back to my mole town, once I am leaving molecules, my first step is moles. So my new unit is going to be moles of CO2. But moles of CO2 is not where I'm trying to end. I'm trying to end in grams. So that means I have to get rid of moles, so I put it in the bottom again. Now, I go back here. My next step does get me up to mass moles, so grams is going to be my last unit. Okay, every time we see moles, we're going to put 1, because that is what we're comparing all other units to. Now, when I go from particles to moles, this number, Avogadro's number, tells us that there are 6.022 times 10 to the 23rd particles for every 1 mole of a substance. So that's what we put in front of molecules. Now, as we're going from moles to mass, it tells us that the conversion is molar mass. So I have to go to my periodic table and figure out the molar mass of CO2. So for carbon, if I look on my periodic table, the molar mass is 12.01. And there's only one of them. So that is a total of 12.01. Oxygen, if I look on my periodic table, is 16.00. And in CO2, there are 2 oxygens. Okay, so that comes out to 44.01. So that is the molar mass of CO2. So now I plug it into my calculator. Remember, whenever we have anything in scientific notation, remember to put it into parentheses. So what I'm going to do is I'm going to multiply everything on top and then divide through everything on bottom. So I'm going to do parentheses 4.27 times 10 raised to the 24th, and parentheses. I don't need to multiply by 1, and then times 44.01, and I get an answer of 1.879 times 10 to the 26th. And then I divide that by my bottom, which is 6.022 times 10 to the 23rd. So now I divide by parentheses 6.022. Instead of using times 10, I can always use my E button. So second comma will give me that capital E to the 23rd, end parentheses. Okay, and then I end up with 312.06 as my number. Now, think about significant figures. So the number that they gave us had 3 sig figs, so our answer needs to have 3 sig figs. So I start from the left, 1, 2, 3. Then I look directly to its right, the 0 to the 2. Zeros don't round up, so our final answer is going to be 312, and then our units are grams of CO2, because molecules cross off with molecules, moles cross off with moles, and all we have left is grams. So this right here is our final answer. Let's do another one. This one says, how many liters of fluorine gas are in 9.4 grams of fluorine gas? So this question is asking for liters of fluorine, and it's giving us grams of fluorine. Okay, so let's go back to our mole town. So it gave us grams, so we're starting in mass mole, and it's asking for liters, which is the unit for volume. Well, we can't go straight from mass to volume, so we have to pass through moles. So to get from mass to moles is one step, and moles to volume is the second step. So again, we're going to set up a two-step problem. I always put the number and unit of what I'm starting with in the top left. 9.4 grams of fluorine gas. So fluorine, when it's by itself, it's part of Brinkelhoff, right? It's a diatomic. So we have to remember that whenever we're creating our formulas, because that's going to change the molar mass a bit. Now, we don't want to stay in grams, so we put it in the bottom right in order to get rid of it. Now remember, we're making our way down to volume, but in order to get there, we have to pass through moles. So mole is going to be our new unit. And again, it's moles of fluorine, because that's what we're dealing with. Moles of fluorine is not liters of fluorine, so we have to get rid of it. Okay, now we're in moles, and we're trying to get to volume, and that's our last step. So, liters of fluorine. Now again, we're always going to put 1 in front of moles, because that is what we compare all other units to. Okay, let's go back to our mole town. When we go from grams to moles, it tells us to use the molar mass. That's the equivalence. So I have to look up the molar mass of fluorine. So if I go here, fluorine is 19.00. But there are 2 of them, since it's a diatomic, so I have to multiply that by 2. So it comes out to 38.00. Okay. Now, going from moles to volume, it tells us that 1 mole of any gas is 22.4 liters. So that's what goes up here. All right, now we multiply on the top and divide on the bottom. So in my calculator, I'm going to do 9.4 times 22.4, and I get 210.56. And then I divide by what's on the bottom, so in this case it's just 38. Oops, there you go. Now you can see that. So it comes out to 5.5411. All right, so let's look at my significant figures. I started off with 2 sig figs, so I have to end with 2 sig figs. So 5.5 are my 2 sig figs, and then the 4 does not round up. So my final answer is 5.5 liters of fluorine, right? Because grams crosses out with grams, moles crosses out with moles, and the unit we're left off with is liters. All right, last one. How many atoms are 9.07 liters of sulfur? So we're looking for atoms, but it gives us liters of sulfur. Okay, so if it gives us liters, that's where we're starting. And it's asking for atoms, which is part of particle park. So we can't go straight across. There's no road that does that. So we have to go from up to moles and then down to particle park. So that's going to be 2 steps. All right. I always put what I'm starting with in my top left. So that is 9.07 liters of sulfur. I don't want to stay in liters of sulfur, so I put that in the bottom so it will cross off. Now if I go back to my mole town, going from liters to particles, my first stop is moles. So that's going to be my first unit. Now, I'm not trying to stay in moles because it's asking for atoms, so I have to get out of moles, so I put it on the bottom. Okay, now I'm going from moles to particles, because that's where atoms is, and that's just our next step. So, it's going to be atoms of sulfur. All right, next up, I have to make sure to put 1 in front of moles, because that's what I compare everything else to. Now, when I go from liters to moles, I'm going from here to here, and what I'm doing is using the molar volume, because 1 mole is equal to the molar volume. Okay, now I have to figure out what's the equivalence when I go from moles to particles. Well, 1 mole is equal to 6.022 times 10 to the 23rd atoms, or molecules, or particles, or whatever it is. In this case, it's atoms. So 6.022 times 10 to the 23rd goes for atoms. Remember, everything on the top and the bottom should be equal to one another. So now, it's a matter of putting it into our calculator. So I'm going to multiply everything on the top, so 9.07 times parentheses, because we have scientific notation, 6.022 e to the 23rd. All right, so that gives me 5.462 times 10 to the 24th. All right, and then I divide that with what's on the bottom, which is 22.4. So in my calculator, I can just do divide by 22.4, and that gives me 2.438 times 10 to the 23rd. Okay, so I started off with 3 sig figs, so I have to end with 3 sig figs. So the 2, 4, and 3 are my sig figs. I look directly to my right, and that's an 8. 8 rounds up. So it's going to change to 2.44 times 10 to the 23rd, and then our ending unit is atoms of sulfur. There we go. That's how we do 2-step mole problem.